Okay, exam 2. In this class, I plan to make it on Canvas. And we're going to work on that from the 12th to the week after. I always forget. From the 12th to the 19th. How many questions? It'll be kind of like the last test, which I think had 10 questions. I'll get back to you on that. I'll make sort of a plan, like a draft. Okay. So between, I think like 10 or 15. I don't want to be too time consuming, but you should be doing some practice. So, okay, cool. Anything else? I haven't made any new homework, so I'll let you know about homework next time. We want to finish 7.4. And just as a side note, I have a goal, a personal goal to get your grades up before the next test, so that way you can like have an idea where you are in the class. I'm working on it. So this is approximating area, and we're using the midpoint rule. And I'm going to try to actually do this bigger. Bring you guys closer. All right, good enough. So we want to use f of x equal to sine of x squared. Use the midpoint rule with n equal to 4. To approximate the area on the interval from 0 to 1/2. To approximate area under the curve on that interval. Okay, looks okay. So first we'll find delta x. And I will draw a little bit of a sketch to help like see what's going on. So delta x will be 1/2 subtract 0 divided by n, which is 4. Okay. Let's scoot. So you could see this as like 4 over 1, take 1/2 multiplied by 1/4 and get 1/8. then we're going to draw. So this is an interesting graph if you put it into Desmos, but the little piece we're looking at kind of just looks like part of a parabola, but it would go up and then start to curve back down. So we're going to draw this. And from the origin, like swoop up, but it would come over again. So we're going to just something like that. So going from 0 to 1/2. And we have rectangles with width 1/8. We're going to break this up into four rectangles. Let's see. So it's going to be 1/4, 1/8, 3/8. Okay. Then we need the midpoints for each of those intervals. So I'm going to listen to the side, and it'll also help us get used to the notation. So the first midpoint, I'm calling x sub 1 bar. So midpoint number 1 is 1/16. And 2/16, the next midpoint is 3/16, which would be x2 bar. 4/16, 5/16 is the following midpoint. Okay. 1/16, 2/16, 3/16, 4/16, 5/16, 6/16, and then 7/16. And we put each of those midpoints into the function to get the height. So we'll find that height to create the first rectangle, the midpoint for the second midpoint, get its height, make a rectangle, and keep going with each midpoint, up and across. From the midpoint up to the curve, and use that as the height. We'll sketch. And then once we get the area for each rectangle, we add all of those areas together. Okay. So the integral from 0 to 1/2 of the function sine of x squared dx is approximately equal to the sum from I equals 1 to 4 of f of x sub I bar. So let's do that. It's the sum I equals 1 to 4 f of each of the midpoints x sub I bar times delta x. Which this will equal, let's see if I can, we'll put it up here. So we've gone from here, which is about equal to this number, and this number is equal to delta x 1/8. Right now we're just going to keep f of each midpoint. So f of, well, actually I've got even the function, sine of 1/16, and then we're going to square that. Add, putting in the next midpoint. Okay, so this is all contained in the same set of parentheses, but for the next term, we have sine of 3/16, and that's going to be squared. And putting in sine of 5/16 squared. And then, let's see, 1, 2, 3, another one. 3, 5, and 7 over 16. Okay, then we close the parentheses. And I put it all into Desmos, Desmos Scientific Calculator. And I got 0.0408. And I was stressing out for a second because I forgot that you need to have your function, your calculator in radians. So don't forget to put your calculator into radians. Okay, I want to do one more, and that'll be it for this topic. Any questions? All right, just to read this really fast. That was our delta x multiplied with the sum of each of the midpoints being evaluated at the function. So take your first midpoint, evaluate it, add plugging in the second midpoint up till the last midpoint that you have. And simplify your answer. If it's involving trig, don't forget radians. Oh, how do you get the midpoints? First, oh, well, there's a formula which I'll write down. But first I found the intervals, and then I found the midpoint for the first interval and kind of used that to build up. So I'll draw a really big number line and explain like how I did it for this problem, but there's also a formula. I'll do that next. Okay. We were going from 0 to 1/2. And for the first part of scratch work, find delta x. Oh, I see, and there's another question. Okay, put delta x down, come back. B subtract a divided by n. This time b, is it b? This is a. 1/2 subtract 0 divided by 4. So the intervals have length 1/8, so we'll find those first. And then we find the midpoint for each interval. So you add the ends of the interval together and divide by 2. But before we do that, there's another question about midpoints. There are as many midpoints as the number n, and the number n can change. So if there's n equal to 5, 5 midpoints, n equal to 10, 10 midpoints, like that. Okay, so this one has 4 intervals. our midpoints. Let's see. So I could either go 1/8 and add another eighth and add another eighth till I get to the end. Or I could just start splitting this up until I have the 4 intervals I want. So I could like cut this in half and cut each of those halves in half. I think that'll help me to sketch the picture better. So we're gonna take the full interval, divide it into 2 parts. Then that will split in half. And this is also 1/8, 2/8, 3/8. So for the first midpoint, we'll plug the numbers right into the formula, which would be take the beginning, add it to the end, divide both by 2. So take 0, add 1/8, divide by 2. That got me 1/16. This midpoint, you take 1/8, add it to 1/4, and divide by 2. That gives the center. Or like the average of the 2 numbers, which is right in the middle. Okay, so this would be 3/8. Let's see. Divided by 2, or times 1/2. So got 3/16. You can keep working like that. The next one, take 1/4, add it to 3/8, divide by 2, and that's going to give you the midpoint. And then in general, we've got the formula for each midpoint. Like if you can't draw a sketch for, if there's like, yeah, an unrealistic number of midpoints that you can draw. You've got midpoint of the ith interval, like say first interval, second interval, we'll call ith interval. So it's the average of the 2 endpoints we'll take. For now, for this example, we're calling this interval the ith interval, which makes this guy x sub I minus 1. And this part x sub I. So the midpoint, take x sub I minus 1, add it to x sub I, and divide by 2. And I've been calling this number x sub I with a bar. Okay, I think we're going to go on to number 2. Yeah. So we're going to use the midpoint rule with n equal to 8. We've got time. Okay, and we're going to approximate. the integral from 0 to 4. Integral from 0 to 4 of e to the root t, e power square root of t, multiplied by the sine of t, dt. Can't see that here. Okay, I did not put this one into Desmos, but I just drew an interval from 0 to 4, and I split that up into 8 little subintervals and found my 8 midpoints, and then put everything into the formula we've been using to get this. Okay, first thing I would do is find delta x. Let's see. Okay, so b minus a would be 4, subtract 0, and then divide by n. Divide by 8. Four over 8 is 1/2. Really? Okay. I did not expect that. That's fine. So we're going from 0 to 4 on a number line. Oh, this would be delta t, change in or width for the variable t. So t values here. Better. Awesome. Delta t is 1/2. And we're splitting this up into 8 subintervals. Let's break it each in half, and then those halves in half. So this is 2, 1, 3. And then each of those will split. One half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves. So the first interval goes from 0 to 1/2, and you find its midpoint. So you can take 0, add to 1/2, divide by 2, which is 1/4. We're going from 1/2 to 1, which you add the endpoints together and then divide by 2. And here that would be 1/4, 2/4, that would be 3/4, just kind of adding up those little chunks. So I think I'm gonna, since this is easy to draw, I'm going to label what all of the midpoints are, but then I can go back and explain how you can find them if you aren't able to draw this kind of picture. So I've broken everything up. I've split this into all of my subintervals. I'm going to mark all of my midpoints. 1, 2, 3, 4, 5, 6, 7, 8. Let's disorganize this. So the first one is 1/4. 1/4 plus 1/4 gets you to the end of the interval. Add another 1/4 to get to the next midpoint. So we're at 3/4. I'm going to do the same thing, add 1/4 and 1/4 gets you here. So we're at 5/4. 1/4, 3/4, 5/4. The end of the interval would be 6/4, so the midpoint we want is 7/4. 2 is equal to 8/4, and this midpoint would be 9/4. And then 5/2 would be 10/4. The midpoint we want is 11/4. That's 12/4 equal to 3, and 13/4 is that point. Almost done. 14/4 is that number there, 7/2. But we want the next number, 15/4. So those are all of my midpoints, all 8 of them. So if you want to go back and check any midpoint, take the ends of the interval, like say from 2 to 5/2, add the ends together and divide by 2. So 2 plus 5/2 divided by 2 would equal 9/4. I'm going to skip checking it. Let's write down what the formula is, put all of our midpoints in, and call it good. Before I erase though, any questions? All right, all of these midpoints sit on the bottom of the board, and we'll get that formula up right now. And actually also restate the problem. So the integral from 0 to 4 of e to the root t times sine of t dt is approximately, so we're going to do the about symbol. So we'll take delta x. Well, I've got all these midpoints on my scratch paper, so delta x. The sum from I equals 1 to 8 of delta x times f of the midpoints, which I call x sub I bar. Okay, this is about this, and this number is equal to delta x, which was 1/8. Oh, I'm sorry, this time it's delta t, and delta t was equal to 1/2. These were supposed to be all t's every time. Okay, so I'm from I equals 1 to 8 of delta t times f of t sub I bar is equal to 1/2. There's a lot to it. Let's just put in the 1/2 part, and we'll put on all the other pieces after that. So we still have the summation sign. From I equals 1 to 8 of 1/2, which it could come out of the sum, but still. That number's there. We'll put all these numbers in next. The midpoints. So that's the sum from I equals 1 to 8 of 1/2 times f of t sub I bar And to save writing, I just left the function written as f. But when you put it into your calculator, you have to use that full expression for your function f, which is e to the root t sine of t. Okay, I'm gonna go here. 1/2 times f of 1/4 and f of 3/4, and then you evaluate the function at 5/4. And then we put in 7/4 and 9/4. And then we've got to put in 11/4, 13/4, 15/4. And I put all of this into Desmos scientific calculator, remembering that I needed everything in radians since we're using trig. And I've got 4.748. What happened? That. 4.748. Okay. So that's the end of this section. But before we go, does anyone have any questions? Okay, so the next thing we're doing is 7.6, when we see you next time. And let's say goodbye.